Active learning is a subfield of machine learning that focuses on making efficient use of labeled data by selecting the most informative instances for annotation. Stream-based active learning takes this concept a step further by considering data streams, where instances arrive sequentially or in a continuous manner. In this part of the tutorial, we will dive deep into the concept of incremental active learning and its role within stream-based active learning. Before we explore incremental active learning, let's briefly recap the main idea behind stream-based active learning. In stream-based active learning, data arrives in a stream, and the learning algorithm has limited time and resources to select which instances to label. The goal is to maximize the learning accuracy while minimizing the number of labeled instances required. Incremental active learning is a strategy used in stream-based active learning that focuses on incrementally updating the learner's model as new instances arrive. Instead of training a new model from scratch each time new data arrives, incremental active learning seeks to leverage previous knowledge and update the existing model with the new information. This approach is particularly useful in scenarios where retraining the model from scratch is computationally expensive or infeasible. Now that we understand the basic idea behind incremental active learning, let's delve into the key components and steps involved in this process. 1. Data stream management. The first step in incremental active learning is managing the incoming data stream. This involves handling the stream's flow, preserving its order, and ensuring that the learning algorithm can process it effectively. Techniques such as sliding windows, reservoir sampling, or stream sampling algorithms can be used to handle the infinite nature of the data stream. 2. Instance selection. The next step is selecting which instances from the data stream should be labeled. Incremental active learning algorithms employ different selection strategies, such as uncertainty sampling, query by committee, or diversity sampling. Uncertainty sampling selects instances for annotation that the current model is most uncertain about. Query by committee selects instances that cause disagreement among a committee of models. Diversity sampling focuses on selecting diverse instances that cover different regions of the input space. 3. Active learning model update. Once the labeled instances have been selected, the existing model needs to be updated with this new information. Incremental active learning algorithms update the model in an efficient way by only incorporating the new instances and avoiding a complete retraining. Common techniques used for model update include online learning, incremental learning, and ensemble methods. Online learning algorithms update the model incrementally as instances arrive, making them well suited for stream-based active learning. Incremental learning algorithms update the model incrementally by adding or removing learners in an ensemble. Ensemble methods combine multiple models and update them incrementally to improve the overall performance. 4. Classifier evaluation. After updating the model, it is important to evaluate its performance to ensure its effectiveness in classifying new instances. Traditional evaluation metrics such as accuracy, precision, recall, or F1 score can be used to assess the model's performance. Online evaluation techniques can also be employed to continuously monitor the classifier's performance as new instances arrive. 5. Model adaptation. Over time, the data stream may exhibit concept drift, where the underlying data distribution changes. Incremental active learning algorithms should be able to adapt and adjust the model to account for concept drift. Techniques like drift detection and concept drift adaptation can be applied to identify and handle concept drift in real time. Overall, incremental active learning plays a crucial role in stream-based active learning by efficiently updating the model with new information without retraining from scratch. It involves managing the data stream, selecting informative instances for annotation, updating the model incrementally, evaluating the classifier, and adapting to concept drift. By leveraging previous knowledge and selective labeling, incremental active learning enables efficient and effective learning from continuous data streams.